The next ascent is a pretty sharp feature.
See it here now. Yeah, there's not much to that.
Oh yeah, it's already blunted off.
So I've got a question for you about Hercules to our ROV pilots. How deep can Hercules go? And I guess how deep can Argus go? And what's the deepest either of you have ever piloted the ROVs, if you know?
Me, the deepest I've piloted, I think, is about 4,200 meters.
Wow.
And Herc goes to 4,000.
I think so.
And Argus goes to 6 if there's enough cable on the winch drum. So sometimes we might only have 4,000 meters on of umbilical. Then obviously we're limited by that. There's different limiting factors. So for Hercules, like typically you have your buoyancy is going to be rated to a certain depth, and your atmospheric cans, some of the cases that we keep electronics in that are not oil filled, they're just at 1 atmosphere inside. They have to be pretty heavy duty to withstand the pressure, so those are rated. In this case, Herc's is 4,000. So yeah, you just have different limiting factors, and you have to go with the one that's the least tolerant.
Where in the world were you when you were down at 4,200 meters?
Not that far from here, really. Like around, well, we're further away now, but when we were down around Samoa, down around Tonga and Fiji a few years ago.
Wow, that's cool.
We zoom on that coral right on the kind of middle of the screen right now.
Yeah, go ahead, video.
It's a gorgeous. Yeah, I almost said I saw a lot of these earlier too. Thanks, that's good.
Okay, full wide, please. Yeah.
These are pretty big. Looks like bamboo coral, probably.
Yep, it's like a dead skeleton.
Hmm. It's kind of sad looking.
Those like little snails on the top branch there.
Oh, maybe,
maybe,
yeah.
They just had the feast.
Zoom in video.
Or barnacles.
Or the last two polyps.
Sounds like a movie I would watch.
The last polyps. Oh.
Oh yeah, it's like barnacles.
Huh. Wow, those are really cool looking. Those are pretty big barnacles.
Yeah.
Is that a hydroid on the top there?
Yeah, remember we saw that giant one of these.
Oh, yeah, that was I think our first watch.
Yep.
Maybe. That's pretty cool.
Wonder if you would still find eDNA around like dead skeletons, or for how long after?
If it was just the skeleton like this,
Yeah, probably not.
probably not, because the currents would have taken most anything away.
No.
Gabby, there's your Brussels sprouts again.
Oh, fantastic. They're not just my Brussels sprouts. I'll share.
Oh, thank you. So kind.
No, thank you.
Except, yeah, Sam doesn't want it.
Saving room for ice cream sundae.
What's on your mind?
Oh, can we zoom on this right in the lasers, please?
Go ahead, video.
Okay. Look more like go whip coral for a second, but just another of these bamboo whips. That's great, thanks.
Okay, full wide. Yeah. Just flattening out. Oh yeah, yeah. Now's a good time. You can bump it up. Oh no, you're good. Are we? Yep. Is Ed still here? He's gone.
Is that a sponge or a coral up there?
The white? Are you talking about, or?
Yeah, like by the lasers.
Yeah,
Yeah.
sponge.
Oh, wow.
Zoom in there, video.
That's really cool looking.
I
Oh
think
yeah.
Chris
now
gorgeous
I
on
see it.
top though.
Wow, that is so cool. That's beautiful. I like that one a lot.
So ammo down here in the lounge, that's, we sampled one just like that.
Ah, okay,
Cool.
cool.
So the team that does the work on the sponge reef in BC is Dr. Sally Lays from U of Alberta and her people. They have these little sip samplers with little straws that have to go in like one of those osculum with the arm and like stay in there for 5 minutes, and that's how they take their samples.
Oh, really?
It's pretty like, wow, it's pretty intense. And then if you disturb it at all, like while the arm is in there, if you touch the sides of it at all, she's like, that's no good. That spoils the sample.
Wow.
It's like super tricky.
Huh.
Is she trying to keep them alive, or?
No, she's taken the water samples. She's trying to get, I guess, information on like their respiration.
Oh, gotcha.
And then if you touch the sponge, it changes how it behaves. I guess it stops breathing or stops filtering,
Oh, interesting. That makes
pumping,
sense.
whatever. Full wide, please. Yeah. So she gets. It's like really hard to do, like with the arms,
I
because
bet.
they're not, you know. And then we get yelled at if we touch the side.
Yeah, the one we got had what looked like a shrimp inside it.
Oh, nice. An associate. Shrimp associate.
Can we get a zoom on that white coral, Mike?
Right under the lasers?
Yeah.
Second here, get in there. Okay, go ahead, video. Gabby,
Oh,
get in here if
Albert.
you want to.
I'm dangerously close to wondering if that's Paragorgia.
Sure.
Probably another corallid, though.
Mm-mm.
Yeah, it looks... It's hard to tell if they're rigid.
Albert, can we get a move? Oh, no, please,
Alexis is saying hemicoralia.
Yeah, I know. You notice that I didn't call it Paragorgia. I just said that I
It's all
want
good.
to.
You did,
full wide
you
video.
did say that, Sam. You covered your bases, so.
Yeah, it's the barren flats. Nice. Yeah, that's right. What? Yeah. Oh no.
Okay, Albert, we've got a few questions about the different mapping that we do. Do you want to explain how we map from the Nautilus?
Oh yeah, I can explain that.
Great, thank you.
But first, 1 second.
Yep.
Bridge nav, step please. 1 second, I'm checking that they actually step.
Yep, you're good.
Okay, they are on their way to step. So the ship has two main sonars that we use for, well, two sonars that we use for mapping. The one that when we are mapping, you can see it on the top left part of the quad view. It's a Kongsberg EM302 multibeam that can map from very shallow to approximately 7,000 meters depth. And what it essentially does, it essentially emits a sound and listens for its return in different directions.
I get it.
In a way that it gets like how far away the seabed is in each one of these several hundred directions that it has. And so we put the ship is moving, and we do one sounding, and it changes its position, it does another sounding, and we keep like accumulating these profiles across the track of the ship, and we move the ship like if we were moving the loan, and with that we can have the top view surface of how the seabed looks like at that point. Depending on the depth of the site that we are mapping, we get higher or lower resolution, so meaning that we can be able to see bigger or smaller things. Obviously, the shallower we go, the smaller the things we can see. And then the other sonar that we have on board is I don't remember the brand or the model, but it's a sub-bottom sonar, and that sonar essentially is a single beam sonar with a pretty large footprint, I believe. I don't actually know the footprint. The footprint is how wide the sonar is on the seafloor. Okay, so how much area does it cover? And that's kind of a cone. It increases with the depth again. So that sonar is used to see the different layers of the seabed. So like when you can see that when you go over soft sediment, like it gets like blurred because there is no hard substrate. When you go to hard substrate, you get like a really intense return and nothing else.
Go for
Sometimes
video.
you see like a white shade and then a thin line, meaning that you have like some mud or sediment and then a hard rock, and it's used for understanding the geology of the site in terms of what layers are there.
Have we seen a living Brussels sprout yet?
No.
We've seen some that were like half alive, I think. Emma, was this the one you were talking about wanting a sample of, or is this, do you think, similar to what you sampled before?
Maybe we lost Emil.
That's all right. We can move on.
Okay. Go wide. Do you guys have a whatever you want from this one?
Yeah, thanks.
Okay.
And Albert, what's the ideal speed of the ship when we're mapping?
The ideal speed is between 8 and 10 knots. But to be able to cover some more area, we are doing 13, or between 10 and 13 now.
Gotcha. Yeah, if you're on the Nautilus Live website and you click on the tech page, you can actually see a photo of what the sensor looks like on the bottom of the Nautilus.
The multibeam looks like a T.
Like a what?
Like a T.
T.
It has like two transducers, one that goes across the ship from port to starboard and one that goes along the ship. from boat to thruster, but I think they are like 6 meters long each or 8 meters long. I don't remember the actual length of the transducers, but they are not obviously not the whole way across the ship and along the ship.
Mm-hmm. Thank you for that explanation, Albert. That was great.
Go for Zoom video.
It's so clear.
So now that you're observing one of these, somebody said, I think it was Sarah, that said that some of them can expel their guts to feed. Is that a quick process or is that a slow process? So is that something that you can see it in 2 seconds to get it out?
Okay, go wide.
Or is
Yeah,
it-
it can happen pretty quick. They do it sometimes as a defense mechanism too,
Okay.
if they're getting attacked and they just like eject them
And
very rapidly.
when they do it, when they are getting attacked, do they lose the feeding system and they have to build a new one, or do they just like throw it away and then get it back? And you know what I mean?
Yeah,
Or it's
I
just a defense mechanism that ends up with
I think
the
it
organism
depends.
being dead?
I think it depends the degree. Let me see.
Still all the same kind of stuff, huh?
Yep.
Yeah, so they regenerate them later.
But for that, I guess they need to have some energy stored somehow, because I guess regenerating your gut must be something energy-wise expensive.
Yeah, yeah, for sure.
And while you do that, you cannot eat.
Yeah.
Oh, but I think you missed your calling as an experimental biologist.
Go for Zoom video.
No, that'd be called torture.
Well, that's what physiology is.
Video, can you zoom in there?
Thank you. That's good.
Like, I like doing experiments, but the problem is that I don't have a very good memory, so I wouldn't be able to like remember all the necessary things to understand excuse me, to understand how biology
Okay.
actually works.
Go wide.
Are we cool for another step? Well, cool. I mean, like,
Yeah, we're getting
do
cool.
we accept another step?
I accept another step.
Bridge nav, can
And
we
we're
step again,
cool.
please?
I'm assuming these are all the same kind of knobby rocks that you're not interested in.
Yep.
Can you go for Zoom? That's good right there. Push in a little further. Nice.
It's interesting, we've seen a lot of these hemicralium that are just covered with zoanthids.
What color are the zoanthids? Are they the pink part or the yellow
That's
part?
the pink is the hemicralium.
Okay.
Oh, I would have thought the opposite. I guess I see it now.
Okay, can you go wide?
But I would say the majority we've seen on this watch have been pretty heavily colonized.
Now, is that colonizing the zoanthids? Are they parasitic? Seems like they obstruct the feeding of the coral.
Yeah, it's usually something that we see when the colony is damaged or unhealthy in some way, and either isn't able to defend itself or loses part of its tissue, and then the bare skeleton can attract a lot of things that are looking for real estate up in the water column. So you see zoanthids, hydroids, barnacles.
So the secondary metabolites keep all that stuff off there, but that's probably the first thing you stop producing if you're stressed in some way.
Well, for corals, it's a lot of like physical defense mechanisms. So they have these digestive filaments that are a little bit longer and can come out and kind of sting or partially digest a neighbor or a zoanthid. And yeah, I think for the most part, you know, if you have healthy tissue, it's just not something
Can you zoom?
that these things that are swimming around the water column are able to settle out onto and start growing on. But if you have like that harder skeleton that's just exposed.
Okay, go wide.
Yeah.
Can you tell whether that's a dropped frame or not? It didn't say dropped frame. Okay, great. Thank you.
Robert, how much distance have we covered? Out of curiosity.
Let me see. almost 1,000 meters.
Wow.
Hey, that's
We're
good.
cooking.
Actually, if you look at the track, like properly, it is 1,000 meters. But if you look just from the beginning to the end, it's 1,000 meters, or slightly less.
Hmm.
Yeah, we have a plan here, guys. We have to keep it moving.
How much further are we trying to go in this watch?
As further as we can.
Ah, that's the plan.
Well, in general, the plan is if you're just kind of seeing mostly barren ground, we'll try to move a little bit faster.
Just cruise over.
Yeah.
Is that an enemy?
Looks like it.
An anemone?
Go ahead. Thanks.
Feels weird that we haven't seen many fish at all. I feel like usually on these sandy areas some pop up. It's just so barren.
Yeah, I think we're still at 0, right?
Yeah.
For this watch. And 0 octopuses.
I know.
And 0 sharks.
Video, can you just go for zoom and I'll have like a close-up of this?
Should call
See
these
what's living here.
the plains of Gorgoroth.
The plains of what?
Gorgoroth. Anybody? Nobody?
I don't know. That's over my head.
Lord of the Rings.
Oh.
Sam and Frodo.
I should know
Yes,
that.
yes, I know
I
that.
should know that. Good reference.
Yeah. But we don't have like a massive volcano spewing magma nearby, so.
Well, we're on a
We're
volcano.
on
Used
a-
to be.
Yeah.
I don't think
Can we,
it's
can we
spewing
get
magma
some-
anymore.
Can
But
we get some magma real quick?
Yeah, there's not a whole lot happening here. Oh, there's a
There's a
little
little
Brito
Brito
star.
This is slowly
Just
making its
one
way.
little guy.
how do they determine that these are extinct volcanoes instead of just inactive for a long time?
Yeah, there's no evidence of any eruptive material that's come out of this, you know, and if it was presently active, they would detect seismic activity or something on the
Yeah.
on the volcano, you know. So, and the type of rock that makes it up, the basalt here on the base, is all volcanic. It's basically solidified lava and magma. So there's no doubt it was a volcano at one point, but back in the Cretaceous period.
So we just missed it.
By 2 years.
Just a little
Overslept.
late.
Video, can you go wide?
Dwight, does Nautilus ever go survey active underwater volcanoes?
Yeah, just before or a couple cruise legs ago, they dove on. I'm gonna forget the name. The one in American Samoa.
Yeah.
What's the name of it?
Can't help you. I remember diving on it.
Valua or something like that. Vialua.
Yeah, yeah.
Another step?
That sounds right.
It's well, I don't think it was erupting at the time that we dove on
Another
it,
step.
but when
Reach nav. Step, please.
there was a NOAA-led project about 10 years ago where they discovered it, and it was actively erupting, and you could see the lava coming out of it and the ash.
Like underwater?
Yep.
Wow.
Obviously, the ROV couldn't get that close to it because it would have melted it. But they got it on video.
That's really cool.
That's really cool. I'll have to look that up.
It wasn't Okeanos or Nautilus, obviously. It was a different ROV. I can't remember if it was Jason or Ropos or Alvin or something. But
I wouldn't like to be there with a human submersible.
no.
I'd rather be-
Yeah, they probably wouldn't have been Alvin, I guess, because of that reason.
I mean, ROVs and submersibles do get pretty close to like hydrothermal event
Oh yeah.
chimneys, but I guess that's a very localized heat source that cools down once you're
Right. Yeah.
feet away from it or meters away from it.
Yeah, we've stuck the temperature probe right into 300 degree, 400 degree
Video, can you give me a zoom?
fluid.
Yeah.
And it's been pretty much fine. Titanium is safe at that temperature, I guess.
I imagine lava is quite a bit hotter.
Yeah. 1200 degrees.
Well,
Yeah, 1200.
That would melt.
That seems
Wow.
hard.
That would melt anything.
Yeah, jeez.
well, like rock.
Yeah.
Okay, go wide.
Titanium has a melting point of like some thousands of degrees.
I don't know.
I do not know.
Yeah, titanium, like welding, is a very challenging thing to do because you can't allow any oxygen to get into the space where you're doing the welding, or else it's corrupted or it's weakened.
Can you zoom on that
3,000
stock
degrees Fahrenheit.
sponge?
So like 1700.
It's as tight as I can go.
That's great.
So you could stick Herc's gripper right into molten lava and it wouldn't melt.
Maybe. I don't know.
Wow.
I think her gripper is
gripper
not
is
not
titanium.
titanium.
Nope.
Stainless and aluminum.
Then it would probably melt.
I imagine there's some important wires and stuff too that aren't quite as.
Well, the
Yeah.
housing for the electronics, the bottle is titanium, right?
Yes.
And when we use those gas tight and major samplers, those are titanium, I'm pretty sure.
Yeah, yeah.
Yep.
Bridge nav, step again, please.
That's a trivia
Okay,
question
go wide.
for our guests. What is the melting point of titanium?
You know, someone just wrote in before you even asked that. It says 3,000 degrees
Oh.
Fahrenheit.
Nice.
They were ready for
Fahrenheit.
that. Fahrenheit.
Oh,
yeah.
can we have a proper measure for
Should we
that?
ask them if they can translate it to Celsius for us? I guess I could probably do that.
Well, thank you to whoever answered that question before we can ask
Sorry, I
it.
didn't mean to
Yeah.
be rude. I just like a respectable unit.
It is 1,648 degrees Celsius.
It's a nice round number.
Well, also actually 0.889, but I left that out.
Yeah.
Careless of you, really.
I know, I know.
What kind of scientist are you?
They're not an accurate one, I guess. So Dwight, what do you think causes these parts of the seamount that are really, it looks almost like sandy here, and the rocks are a lot smaller looking, versus the areas of the seamounts that we've seen that have been really like bouldered? What do you think causes the
Go for zoom video.
difference in the topography there?
Just want to take a look at this shrimp real quick.
Life, how exciting.
I know, right? It's the only life. Go a little wider. It wasn't very stable for that. Look at his beautiful legs.
They're so cute when they
I
swim.
know. You can go a little tighter. Okay, go wide. Oh, that's a really big swing and we're about to head up. Yeah, let's wait for the swing. Do you think that's the right thing? Okay.
Yeah, for sure.
You want to give me a bit of a zoom? Good.
Cool colors.
I know. The combo is nice.
Like the crinoid thing.
Oh yeah.
Like yellow
Go
and black.
go tighter.
Yeah, that is cool. The like dark feathers. Feathery looking things. Feathers.
So Mike and I were having a conversation earlier today about ROV technology, and I'm curious, Mike, is there any way to have an ROV go wireless?
Wireless. No, there's some underwater wireless technology, but it can't do the distance.
Essentially because that technology is based on light and
Yeah, that's right. There's some, what do they call it?
optical modems.
Yeah, it's like BlueCom is I think a Teledyne one or something. It's kind of, you can use them for like relay stations for like, there's some papers out, I don't know if there's anything actually made about like applications for like AUVs and stuff like that where they can go and like go to their, go to the station and download subsea and stuff like that. But to control an ROV, can't do anywhere near this kind of distance. It's only like, I can't remember the numbers, but it's, you know, it's probably like a few meters or something.
Oh, wow.
Just you have to think like in how many fiber optics do we have here?
In the umbilical, you
Yeah.
mean? There's 3, and then there's 2 that we can pass through.
But we are only using three.
We use one for telemetry. One to control the vehicle.
And
we have like a guest one there.
Whoa, what's that?
What is that?
Yeah.
Fallen over sponge.
Oh,
I
yeah.
think.
Oh, yeah, I see it now.
Because what I was gonna say is like this
Go
is
for zoom.
also optical technology in the umbilical.
Yep.
But like in water, it's the light
That's
is 1.3 times as low. Like
Thought we had our
the
first fish.
sound speed, the light speed is
Okay, go wide.
1.3 times slower.
It's like complicated by all the
So
like particles in the water. and stuff.
Plus all the complication for the scattering medium.
Yeah.
And blah blah blah. No, it's just. But I think it was last year, 2 years ago. I think it was. We were doing some experiments with people from Hui, with a lander, where we had an optical modem on Herc, and we had an optical modem on the lander, and the lander was recording Herc, and we were getting the feed live without an actual wire connection to the lander.
That's really cool.
But that was like 20 meters or 50, like short range.
Yes.
What we would say short range. No. The wireless technology we have underwater is like the speed of
A fish.
the first modems that you had at home.
Oh yeah, our first fish. Can we do a zoom?
Yay, life.
So is the capability of those modems limited by power output?
No, essentially like the sound it only travels at 1500 meters per second.
Ooh.
Plus you have like your
This is
bandwidth
too
is
smart
not
for me. It's too fast.
as big as what you have in light. It's like it's a whole different technology. It cannot be pushed very much farther away, I think.
It works pretty well for controlling AUVs, though.
Well,
That is what it's used for mostly, right?
Mm.
Acoustic modems.
yeah, you don't control them. Like you might send them
optical mode.
basic
Gabby, is that another
instructions,
fish just to the right of the
but you
laser?
are not like.
Not like an ROV.
Something
Yeah,
to the
yeah.
right of the lasers.
Yeah.
There's a little fish down there.
Oh,
we
I
could
see.
do a zoom on that.
A little fish.
But yeah, most AUVs operate with a modem. Actually, they use the USBA channel, the USBL channel for the modem. So they get both the USBL positioning and the modem within the same sensor.
The Woods Hole group, I think, got 50 meters or more with the optical modem.
With the optical one.
Yeah.
Oh, that's,
Go for zoom.
Yeah, but that's
that
still.
seems like incredibly impressive. But
Yeah. At what depth did they get that?
Like 700-800 meters.
wow.
It was,
The problem is that if you want to operate at 50 meters depth, you cannot have one modem on surface and the other one
yeah.
because you have all the sun and everything.
Right. So I mean,
Can we
it's-
But
push it
still,
any
it's a
closer?
very great achievement. Like
What's that, Sam?
Can we push it any closer?
Okay,
I'm
I'll
as
give
tight
it a
as
go.
I can go.
Yeah,
Okay.
yeah, yeah.
that's
I'll get a little closer.
that's a new fish. I haven't seen that on these cruise.
It's really not moving at all.
the small
Okay.
guy.
Yeah.
Yeah.
Sometimes
Yeah,
that's
good.
no,
Gravity
you're right.
tanks.
You got what you need?
Yep.
Yeah, you're right. I should have done that for sure. Go wide. The temptation.
Yeah.
You're like 3 meters away of that, probably. Okay. Ah, okay.
So the follow-up question to this technology discussion is, do you think that that is the eventual goal, is to have wireless ROVs, or do you think the technology is moving in a different direction?
So there's like an approximation that they use of wireless, which is having a vehicle carry all its power on board and controlling it through an extremely light and disposable just fiber optic tether that's just very light, that a vehicle doesn't feel it as much and is allowed to go much farther away.
Yeah, we were talking about that earlier, Nick. It's
Yeah.
like somebody makes them and they kind of just come in a tube, right?
Oh, really?
Yeah, and it's
Can you
just
give me a
like
zoom?
I guess I picture it being like the XBT
Yeah,
copper
they're like,
cable.
I
like
know,
it just comes out of
I-
a can and then it gets severed
Yeah.
eventually.
So that allows you to do some of the deeper work. Like when I say deeper, I mean very, very, like the whole way deep.
Like Marianas Trench?
Yeah, and that's how they do ROV work there.
That's a cool sponge.
Yep. It allows you to extend much farther horizontally as well as much farther vertically.
Yeah. Nereus was like that, right?
Yep. And then there's the Nereid hybrid. Yeah.
Yeah, I think Nereus had a optical tether, fiber tether of 20 kilometers or something.
Wow.
Whoa.
Okay, go
Wow.
wide.
And it was literally in like a coffee can size device, yeah. They don't, it's disposable. Oh, you mean when they manufacture it? I don't know.
That's machine work.
Yeah. So I think I just kind of had a realization when I asked, like, kind of the pejorative statement, like people doing the research. There's probably not a lot of like commercial manufacturers who are
20?
doing this type of work, is there?
We're gonna step 20 now.
So, like, I think the
Bridge
Teledyne
nav.
group
Can
bought
we
the,
step 20
bought the
meters, please?
patent or the license from the Woods Hole group. So a lot of the R&D is done by research organizations like, you know, engineering development universities that do that sort of work. Woods Hole Oceanographic, Scripps Institution for Oceanography, those
Yeah.
sorts of places.
My
And
lab.
then- yeah.
My lab
Alpha
has licenses to companies as well. My PhD is licensed to a company.
Nice. Bringing in royalties.
Not yet. First, we have to pay the patent.
Yeah.
Yeah. The University of Girona policy is that the authors don't get paid before the cost that the university had for patenting all the stuff
Right.
is covered. But I guess I bet most of the it's a thing that makes sense actually. Like,
Yeah.
but yeah, there's a lot of development that is being transferred.
But it is a niche business. There aren't a whole lot of groups out there that can profit off of deep sea optical modem technology yet, right? And
Well, even building ROVs, is that something that's done commercially, or is it kind
Yes,
of?
yes. There
Oh,
are
yeah.
several companies that do it commercially. Also AUVs.
Yeah, the oil and natural gas companies use a lot of ROVs and AUVs in their work.
Yeah, but they are not very willing to change things. Like, for instance, the new technologies like the modem, the optical modem, if it worked, like their standards are so high that they are, like, you have to prove that your thing works extremely well before they actually get into some operation. Mike has experience there, so he can talk about that.
Yeah, they want reliability over like cutting edge generally. I mean, it's just a different thing. Like, I mean, I think most of those
Bridge nav, step list.
those industry companies, they have numbers of ROVs like 1 to 200 like or
Whoa.
more like each.
Whoa.
So they're kind of
Video,
like,
can you go for Zoom?
I'm sure they do special projects and stuff, but for most of the things, they're not trying to reinvent the wheel. They're just trying to make something that's a bit bulletproof.
I know that, for instance, SMD is a big company in the UK. They are launching a new concept for ROV, or they kind of posted a new thing on their Facebook, and like they had a thing going on September or something. It was a few days ago, saying that they are
Okay, go
kind
wide.
of developing a new set of vehicles from their fleet that it's going to like be as reliable as the other ones, but with more capabilities and blah blah blah. So, I mean, it's evolving. It's evolving, but it's not evolving very fast in terms of market-wise. Probably, I don't know.
I think there's different, it's different stages. There's some things they want, I guess, and then they'll innovate a lot. Like, you think about the Schilling like T4 arm that they have. That got made from like the first version, commercial version, to the fourth version. That was really aggressively like reiterated and made great. But now there's like, I don't think there's really any changes to it anymore, because I think it just does what it needs to do now.
Yeah,
It doesn't break very often, and so what
once you have a stable product, you don't want to change it. It's stable. Bridge nav, step please. No, but the ROV systems are getting more and more small automation parts, like I don't know, things that they can follow some shapes
Okay, go
and
for Zoom.
things like that. But that's where probably the most advanced things are there. That and the improvements in navigation technology,
That's good.
probably, I'd say.
Gabby, I'd also be interested in a quick zoom on that big one that was behind this
Yeah,
guy.
way off in the distance.
I don't know if we're going that way though.
I might be able to. Is this what you want for this guy, or do you want more?
Yeah, that's fine for this.
Okay, go wide.
It's a healthy one though.
it's in a good spot.
Prime real estate.
Yeah, proud on the rock. It's a good rock.
It's a great rock. I wish that coral could hear. Probably could use the moral support.
It doesn't need moral support. Look
You
how
don't think so? I feel like
This
we all
one might need some help.
I feel like
What's
we
going on
all
here?
need moral support.
Is
Maybe
it just a
not.
white one?
Can you go for Zoom video?
If you only stick to the plans, then you wouldn't.
You're right. Probably true, actually.
Oh,
I'm
this
just
looks like
kidding.
This one's cool.
I stick to the plans, and I
another-
also need moral support.
I think you're doing a great job, Albert.
It's like it's another colonized one.
Go wide.
Albert, can you tell me the depth at waypoint 3, roughly?
$1,800.
Thank you.
It's about 100 meters uphill. So we say
That's good for that one, Gabby.
1,800, 1,770. These are 10 meters contours. And the white whites are 100 meters.
Go for Zoom video.
Yeah, more colonization. These ones always look funny from off in the distance, but
Which color's the zoanthids?
the like the bigger looking polyp
Oh, okay.
things.
Yeah.
I'm not tan. I'm not great with colors.
Beige, maybe? I'm not sure.
What was that off-white word that you kept using, Gabby?
Ecru.
It's not a crew.
It's not ecru.
I don't think. But that's good. Thanks.
Okay, go wide. Are they giving you lip?
I got like.
Sandier than I expected here.
What are you guys expecting at waypoint 3?
A summit.
Oh, thanks. Is that the top?
No, no, no,
Okay.
no.